So welcome everybody. My name is Tom White and I'm here to talk to you today about the Siemens Manufacturing and Automation Curriculum. It's something that we're very excited by and really pleased with the way it came out. So as we go through this, hopefully you'll find something in here that speaks to the kinds of things that you need to do. So what we did is we came up with a way to write a piece of curriculum to really get this stuff across. So it's like an advanced manufacturing cross with a bunch of different things that we think will be helpful to the young people in our country. So before we get going, there we go. We want to introduce ourselves. And I'll let Dick jump in here.
Thank you, Tom. I'm one of the old guys on the right, not like those handsome people to my left as you're looking at that picture. I have been involved in teaching and learning as a teacher and administrator and so on for quite a few years now, and also was involved with Tom in creating a program called Project Lead the Way, which we operated for 10 years and ended up working with all 50 states to have schools in that program. We then went to the Southern Regional Education Board for a number of years, and now we're helping Siemens with the development of this curriculum. So I'm happy that you were able to join us today, and I'm going to turn it over to Tom.
Okay, and the handsome guy in the middle is Matt Bruce. He's our contact at Siemens, and he and I met about 5 years ago, and basically he started helping with the program, and he liked what we were doing, and a few years later we were getting together to create a new program. So Dick was being very kind about us being the two old guys on the bookends, but we're both semi-retired. We are trying to really improve things in the United States, and I think this is going to do it. So I'll let Dick talk to you about rigor and relevance.
Thanks, Tom. I just want to talk about this one slide as a kind of looking at what Tom's going to talk about here from the 10,000-foot level, so to speak. We've all heard this term rigor and relevance, and it's really important because we want whatever programs that our students are involved with in school to be challenging and motivating and something that will really benefit them and prepare them for the future. And so to begin with that is the need to make sure that the curriculum is project problem based and that those projects are very authentic and that they are standards based. And the actual standards that we are using, there are 4 sets of national standards. The college and career readiness standards for English language arts and mathematics are utilized in here, including the 3rd set, the next generation science standards, and the
Well, I think Dick finally lost his connection.
Oh, can you hear me, Tom?
Yeah, I can hear you now. You disappeared there for a second.
Hello?
Well, okay. I'll pick up from here, Dick, and hopefully it'll come out the way you wanted it.
Can you hear me, Tom?
Yeah. Go ahead, Dick.
Well, I don't know what happened. I'm getting an echo. Okay, now it's good. Can you hear me now, everybody?
Yep.
Okay. So I was talking about the standards-based aspects of this curriculum and mentioning that we had the college and career readiness standards for English language arts and mathematics, the next generation science standards, and the standards for technological literacy. The fifth set of standards are the ones that Tom and I have written originally. They are the technical content standards that relate directly to each project. So we wanted to make sure that this thing really hits students, and they would want to be really engaged with this. And one of the things that really contributes to that is this concept of familiar context. And when you look at the examples of the projects that Tom is going to show you this afternoon, is you're going to see things that students will find familiar. They're not. I remember, seeing a technical drawing class, for example, and kids were making technical drawings of items such as a packing gland or a gusset plate. And, you probably all remember things like that in perhaps in your years as a student. And really, hard for kids to relate to those kinds of things that are totally foreign to them. And we wanted to stay away from the kinds of programs that are in learning that require students to memorize software commands. We didn't want that to be the driver here. There are tutorials in the curriculum that are designed to teach selected procedures, but they're presented to the students in the project just in time when they need that. And so that's is an important part of it from that perspective. So having the students deal with authentic problems and use a design process and make them be original thinkers and problem solvers and work in teams is the kind of learning experience that's going to prepare students for the next level. And so that's basically the message I wanted to share with you for you to think about as you're listening to the rest of this presentation. Thank you, Tom, and go ahead.
Okay, I just wanted to point out the team here. They're a group of students from Arkansas who, if you notice, they all have bound notebooks, and they're all keeping track of their daily activities. And a lot of times they'll even get that chart paper out and mount it up on the wall. Those of us who've worked in industry, we know that, hey, this is the way teams work. So there are several pieces to this. There's no cost to the schools for the curriculum or the software. Siemens has worked very hard to make this happen, and they know that there are certain things that get in the way. And one of the things that we've been able to do is to take industry standard software and figure out inexpensive ways to implement it. This young man was on one of those teams that was in the previous picture, and he's got a PLC there, and he's using that to control some very small model pieces. And those model pieces have 24-volt connections, so we can just run them off a standard PLC. And Siemens has made a class pack of these things available at a real reasonable rate. So if you had to go out and buy one of these things, full price, you could never afford to do a class, but the whole class set is, under the price of one. And they're also going to spend some time learning CNC. There's a milling software that comes with it. One of the pieces that we'd like to have the students do is to learn G&M code. They basically go by hand, but this was leading up to one of the projects that the kids do, and they have to make mating parts. And so with different team members designing different parts, they have to talk about, things, tolerances and dimensions and, all kinds of things that are really important when you get around to actually running a manufacturing program. So we use all the standards. Dick talked a bit about those, so I won't bother redoing it. I'll just show you this young man here decided that he wanted to do his initials in a cursive. So he hand programmed the cursive letters, and he using that to run a milling machine in order to produce it. Whoops, way too fast. Okay, there we go. So generally what students will do to learn G&M code is they take their letters and they have a series of points. And from the series of points, they start assembling their G code by hand. And if you look, CJ has done this, and he milled out his letters, and then he took a little piece of plywood so it would look better, and he milled this piece of plywood, and he's got quite a bit going. And we also believe that students should present. And so this was one way that the students presented to authentic audiences. There are a lot of different ways. Sometimes they have a team come into the school just to listen to their presentations. And this happens to be like an open house type of thing where people from the community would wander through and the students would talk to them about all the various things that they've been working on through the course of a year. And this one young man built a automated clamping, feature for like a 6x6 post type of thing. And we use, a lot of Siemens technology, and it's not exclusive, but it's very heavy into the Siemens technology. And this young woman is one of the, this is her first foray into this. And, it's really funny how once you get started, people become fascinated by what you do. And what she had done is she took an object and she drew the object, made some changes to it, and then she 3D printed it out, and she's basically running through how that process works. So what you're looking at is one of the projects in the second course is to take something, redesign it, and so right now they took a clothespin and they printed the clothespin up. The hardest part was getting the spring just right. And so we have the kids use this process, and I'll talk more about that in a second. And so what you're looking at is a slide that came from the National Association of Colleges and Employers, and they talked about the top 10 skills that they really wanted to, have their future employees, master before they came out. And as you look at all these things, most of it is, what we call soft skills or the 21st century skills. How do you embed these things into students so they're always, on the up and up? And of course, just these skills aren't enough. They also have to have some technical skills too. So that's all a piece of it. And so they run through this process where they're given a problem and they have to do a little basic research so they understand the problem. They rephrase the problem. They understand why they're doing it. They go through this process to come up with a prototype they'd like to build. They build it, they test it, they analyze it, and they basically go back through and they iterate. How do we make it better? How do we make this so it better fits what we envisioned as our future was going to be? They finalize the project and then they have to communicate about it. We showed you some examples of the communication. So this young woman was, she was on the news. She's from Alabama, and she had worked with a disabled vet to design a prosthetic foot so he could walk more normally, fit a pair of shoes. So if you think about the design, it might be Bill Barr's worst nightmare, Bob. So at any rate, we go through and, she worked and she got it working for them, and the two of them appeared on the local newscast, and then that was picked up by the national feed, and they had her, on one of the morning shows where they interviewed her about the process. And if you can make the national news from high school, you're doing really good. So what I'd like to do is to kind of walk you into the curriculum, show you a couple things, just so you get a flavor for it. I'll show you where you can download it and take a much more in-depth and closer look. So what you're looking at now is the curriculum itself. It's a PDF edition. This is a short one at only 871 pages. So I'm just going to pick a few pages just to allow you to see what's in here. So let's take a look. All right, so we've divided the course up into 4 quarters. And the first thing I'll tell you is there's way more than you'll ever get done in like a single class period. But if you're at a career and tech center and you want to do all the projects, you'll have more than enough to fill in, for a full, morning session or an afternoon session. So the first quarter is coming up to speed on design for manufacturing. So they're designing an Archimedes screw. So everybody starts there, and then it says pick 2 of the next 4 projects. So people have choices. If different student groups want to use a different project, they're more than welcome to, because they're going to get the same learning just with a different setup. So there's a reverse engineering project, and here's a set of bolt cutters that students had measured up and designed and built. And if you take a close look at it, you can tell that okay, they came really close, but it wasn't perfect because it was students on their first piece. A winder for kite string, and if you take a look at that, this was one that was designed back in the 1900s or so. So it's quite an ancient design, but they can come up with it. And the last one was basically a blow dryer caddy, so you can hang your blow dryer up near where you plug it in. Second quarter, we get into milling. So there's an introduction to G&M codes, speeds, feeds, and everything that goes with that. And they're going to make an engraved nameplate. And then they're going to select one of the next 2 projects. One is a soda can opener. One is a game piece. And obviously, students can, take whatever their hearts desire. And then one of the next 2, and these are basically 2-part projects where one part has to fit another one. So one is a split mold, and you can cast those with all kinds of things. You don't have to, design them so you can pour aluminum. You could pour chocolate, or you can pour soap, or, whatever comes to mind. The third quarter, we learn about PLCs and how do you set them up to make them work. So this was one, basically it's a conveyor belt with a counter at the end. And then select one of the following 3 projects. So there's a garage door control, where it opens and then automatically closes when nothing's in the way. Like in a commercial aspect, when you have to heat the air on the inside or you're air conditioning the air on the inside, you want the door open a long time. There's a sun tracking solar collector. So basically it's, you got to design some system to keep track of where the sun is so you can, turn the motors and get it to point in the right direction. And then there's one called sort by color. So the system takes a look at the various colors and decides what to do with them. Then there's a choice of one of the next 2. One is the elevator control system, and I don't know if you knew, but Siemens was actually the gentleman credited with the modern elevator. So it all came over the last 150 years from that. And then there's a parking lot gate where you have to enter in the right logic to get the gate to open and then drive through and then let the gate close behind you. Fourth quarter, we take a look at pneumatics and how that all works, and how do we get these different components to talk to one another. There's an automatic pneumatic feeder system, so it's like part after part goes into the right place. You saw the picture of the young man who designed a automatic clamping system for the piece he was demonstrating. There's pneumatics, solenoid schematics, handshaking, and that type of thing, a color sorting operation. And if you think about, all the various Amazon and FedEx and UPS and all those different things that are reading conveyor systems and getting those barcodes so it goes to the right place. And then finally, an automated work cell for CNC. So we talk about handshaking. How do you get a robot to talk to a mill, to talk to a PLC, and that type of thing? So those are all the various projects that are embedded in this. So let me just hop. All right, so this was one of the projects out of the second quarter. All right, this is the box with an interlocking top. So if you think about what has to happen, the top has to fit the bottom, and there's lots and lots of tolerance dimensions here that has to happen. So every project starts with just a introduction, where it goes, a purpose, so the students and the teachers understand what the point is. There's a series of concepts. It allows the people looking at this to know exactly what are you covering and what things are important about this particular project. Some videos that Siemens produced so you can see how this actually fits in the real world. Kind of an outline of the concepts being covered. And then we get into standards, and there's pages and pages of these things as each project has a different set of standards that it relates to. And a lot of times what we did with the standards is we took the major standards. We didn't take all of them that you would touch upon, but we're going to go back through and have another look at that. So people have a chance to, because every state is a little different and they want to see different kinds of things there. So we're working with people who are reviewing to update these things so it actually makes sense. And let me just hop forward. Oops. There's also a table of contents. There we go. There's an essential question for each one. All right, so this essential question basically talked about that box. And there's a student scenario, because normally if you're working for a plant someplace, somebody comes up to you and says, okay, here's the problem, and we need you to come up with a solution. And it's not an ABCD, it's a, here it is, here's the design requirements, here's what we need you to do. And then they get out of your way and you're supposed to do it. So as we move along, there's a daily plan. And we all know how well daily plans work. By the time you get 15 minutes into it, it's really someplace else. So each one of these pieces are links. So when we talk about the design process and engineering notebooks, there are documents in the curriculum that support those things. So everybody knows the first thing. We give the teacher a list of vocabulary terms so they can make sure that all the students are coming up with the same understandings. There are places to get more help. And then there are pieces like, okay, if you need to learn CNC, there's a link that'll take you right to it. And so it begins with coordinate systems and that type of thing. And it talks about how you set up in a drawing program. So when you get to a manufacturing program, it makes sense and you can really get that back to where you want. So there's a bunch of different ones here that they can access, because we don't want to tell them this is how you're going to solve the problem, because that just teaches them to follow directions. And what we want them to do is to come up with their own unique blend of design and how do we approach it so they look very professional at the end. So as you get through all these various days, here's the vocabulary. And then we give them resources so they can look things up on their own. So if they need help with CAD, well, here's places you can get help with CAD, engineering notebooks, how to write an engineering report, some videos and other things on CNC machining, some resources on cutting tools and work holding, and what is G code type of thing. So each project is like that. So if I jump ahead, let me just and this is a project that's sort by color. All right, so we talked a little bit about that, and you'll see this is set up the same way. All the concepts, the outlines, standards. Yeah, we're not quite there yet. The essential question, and then the student scenario, which basically introduces the whole thing to them. And then the daily plan. And there's some similarities, but each one is slightly different. So, if we wanted to say, all right, let's use a relay to control motor direction. And so it starts with, all right, so you want to control the direction of a motor. If you don't know how a motor works, then you're not going to be doing much. So we talk about motors and switches, and then we get into relays. And, this is a relay that's fitted to what's called the DIN rail. And, inside cabinet where all the PLCs live are these rails that we hang everything on. So this walks them through not only the electrical aspects of it, but also the mechanical aspects. How do you put wires in and that type of thing? How do you read schematics? So we're very interested in having that work. So at that point, let me go back here. So we had a closer look. And this is a place where you can go to download the curriculum and more information. We are always updating, so this is a place to get the latest updated curriculum, because when I find mistakes, broken links, or things like that, I just fix them and I can post it up again. So I'd like to post our contact information, and it's got our contact information along with our email addresses, and down at the bottom is the link to the curriculum. So I'd like to open it up for questions if anybody has one.
And Tom, this has been being recorded, so people will have access to it afterwards, correct?
That's correct. So let me just see.
Just so everybody knows, you can go to the chat function and type your message in a question, and we'll respond to it.
And the other thing I'll say is we also recorded an introduction to course one. And all right, do you have completed course? So one question was, do you have to have completed course one in order to do this? And I'll say it a qualified no. If you're pretty decent with any kind of a CAD program and design, you could probably wade in and make this work. It would be better if you did course one because that leads into course two. But then there was a question, is there an assessment for students at the end of the course? So Siemens has a series of different pieces that we can use. There is certification exams for Solid Edge, and it's like an introductory Solid Edge certification. The second one is much more advanced, and the third one is a professional. And we've had students take all three exams, and they did pretty well. There's also a CNC introductory certification that they can qualify for. And so that's another possibility.
And Tom, so those certification exams are what we would call summative exams at the end of the course. But throughout the curriculum, there are lots of formative assessment tools, such as rubrics and so forth, that are available to you to utilize to work with students to improve their ability to progress through the course and to master certain skill sets.
Right. There was a question that says, where is the link for information for course one? And it's this same siemensdesign.tomwhitestem.com. And both of them are really in the same spot. You just register, and that basically enters your name into our database, so we can go to Siemens and say, hey, look what we're doing. You should be happy. So when you get that far, it'll help you out, and it'll help us out, so we know who's using the curriculum and where. So right now, the first course is being used around the world. I think it's something like 32 countries are using it, and it's not quite in every state of the union yet, but it's approaching that point. Are there any other questions? Well, I want to thank everybody for attending today, and this is recorded, so you're going to find that there's be a lot more people looking at this in the future than there are today. So thanks for being part of it. And Dick, you got any final words?
Yeah, just one thing. If anybody would like to speak with Tom or myself or Matt or any, to one-on-one to have questions answered or whatever, we'd be more than happy to speak with you.
Well, I want to thank you again, and I wish everybody a wonderful week, and hopefully you'll have an enjoyable weekend, and we will hopefully talk to you soon.